Good morning or good afternoon, everybody. So my name is Anne-Sophie Robs. I am a product manager at KAMIKA, and I'm going to present you today the SKAPHIA, which is the shielded EPMA for analysis of highly radioactive samples. So this is the outline of the presentation. First, I will present the KAMIKA solutions for radioactive materials. Then I will give a very short introduction about the EPMA technique. And then I will focus more into the SKAPHIA and its key features, and I will end by showing some applications of SKAPHIA. So let's first introduce the KAMIKA solutions for radioactive materials. KAMIKA is providing high-end analytical instrumentation. So here you have the secondary ion mass spectrometers, the SIMS. Over there you have the 3D atom probes, the APT. And here you have the shielded SIMS and shielded EPMA made by KAMIKA for the analysis of radioactive samples. Now let's talk about the EPMA technique. EPMA stands for electron probe microanalysis. So it works by bombarding a sample with a focused electron beam. So typically the energy is between 5 to 30 keV. And we collect the X-rays emitted by the samples and the various elemental species present in the samples. And then the X-rays here are selectively diffracted by a crystal according to their wavelengths, and they are sent to a detector to be quantified here. And so the sample composition can be easily identified by recording the wavelength dispersive spectrometer. So here by moving the crystal and the detector here along different angles. So the WDS spectrometers over there, so WDS stands for wavelength dispersive spectrometer, operate based on Bragg's law, and it uses various movable monocrystals and as monochromators to be able to probe almost all the elements of the periodic table. Thanks to the WDS technology, EPMA can determine the concentration of the elements and also shows the distribution of these elements in a solid specimen. So for example, here you have a WDS spectra of rare earth elements. And so by measuring at the peak position and the background positions, you can determine the concentration. And by scanning the sample, you can have access to the distribution of these elements in the sample. So the EPMA is a non-destructive technique because it uses low energy electron beam. We can probe quasi all the elements from beryllium. And it's a very high sensitive technique because we can have access to detection limits down to 100 ppm, so that is to say 0.1 weight% for EV elements. EPMA has been linked to KAMIKA since the technique first appeared on the industrial scale. Indeed, KAMIKA was working in close collaboration with Professor Raymond Castin. And KAMIKA introduced its first microprobe on the market, the MS85 here in 58. So worldwide acknowledgement came quickly, and this instrument has since benefited from continuous improvement and adaptation to the new analytical challenges. So the analytical performance of the EPMA has been recognized in the nuclear field, and so KAMIKA developed shielded instruments. You have here the first one, launched in 74, the KAMIBAX-R. Here we have the S6R, then the S6100R, And very recently, in 2020, Kamika launched the last version of shielded instruments, the SKAPHIA. Now I will present SKAPHIA and its key features more in details. SKAPHIA is a unique shielded electron microprobe on the market for the analysis of highly radioactive samples. So it is derived from the field-proven Kamika SX5 Tactis, so it offers benchmark EPMA performance, robust electronic systems, modern user interface, and user-friendly software. And the system has been designed to accept samples emitting alpha, beta, and gamma radiations with a maximum acceptable radiation level of 111 gigabecquerel. Here you have a picture of the first SKAPHIA at the Kamika factory in March 2021. So before the shipment to our first customer, CEIE, which is the China Institute of Atomic Energy. So here are presented the SKAPHIA key features. So we have a dedicated design based on the state-of-the-art Kamika WDS, so we can have up to 4 WDS all around the tool. We have a larger WDS than the common EPMA tool in order to accommodate the shielding while still allowing optimal spectral range. We have modified the spectrometers to enable the introduction of large crystals, and the shielding has been designed to allow light elements measurements. And we have also put in place specific maintenance and emergency procedures to remove manually the samples from the analysis chamber. Let's focus now on the shielded spectrometers. So you have here a picture of the inside of the spectrometer. So you can see here the Dinal shielding at the entrance of the spectrometers. So Dinal is shielding made by tungsten alloy. And over there you have the shielding around the counter. And these specific shieldings enable to reduce the detector background noise while reducing the signal to background noise ratio changes when the sample to detector distance is altered during the stage movement. And it also protects the gas flow proportional counters from the gamma radiations. Compared to the SX100R, the last shielded version, the spectrometers has been modified so we can introduce large crystals to diffract the X-rays. So typically between small and large crystals, there is a ratio between 2 and 3 in terms of counts. So this feature is especially of interest for trace elements analysis, and it divides by 2 or 3 the measurement time. 2 different sample holders can be used in SKAPHIA. The first one can accommodate 1-inch sample size. So you have here the sample of interest, and over there the references samples. And here you have a sample holder accommodating 1.25 inch, and you have the reference samples all around. Here you have a picture of the sample holder on the stage. So the stage is also shielded, so it's very heavy, up to 60 kilograms. And compared to the previous shielded version, the SX100R, the stage has been reviewed, and we have improved the position reproducibility better than 2 micrometers. Shielding of the stage is mandatory to reduce the background level due to radiations. And here you can see the differences between neodymium quantitative profile obtained with shielded EPMA and the non-shielded EPMA. So really the shielding of the stage improved the sensitivity. Let's talk now about the different SKAPHIA detectors. So in addition to the 4 wavelength dispersive spectrometers, SKAPHIA is equipped with an optical microscope, so with the same Cassegrain optics as the conventional EPMA for enhanced analytical performance, with a secondary electron detector, which has a special orientation and which is protected against the gamma radiation. And finally, there is a backscattered electron detectors, which has motorized retractable shielding, and the shift of this shielding is automatically operated through the software. And last but not least, SKAPHIA is also equipped with electron dispersive spectrometer from Bruker. So it has been developed with dedicated design with a shortened and curved EDS detector to perfectly fit with the analysis chamber of SKAPHIA. So here you have all the specificities, which means an active area of 10 micrometer square, the common energy resolution of 129 eV, and also the detector is retractable to reduce the contamination with an automatic valve. And the EDS steering and all the data are fully integrated into the SKAPHIA PixSight software. In nuclear environments, safety is the first priority. So in case of emergency, the sample holder can be easily and quickly removed manually from the analysis chamber. So here you have an overview of the procedure. So the stage can be manually positioned at the reference position. Then you have manipulators outside the hot cell to enable to go down the full stage block. And then you can easily remove the sample holder from the stage. To continue about the safety, the maintenance has been improved on the SKAPHIA compared to the previous S6100R shielded EPMA. So a hoist has been added on the tool. So this will help to lift the whole column and reduce the intervention time. Also, all the shielding and fixings has been optimized to improve the intervention efficiency. And it's also possible to use the hoist to lift the spectrometers and the spectrometer cover. And of course, all the electronics is located outside the hot cell. And to finish this presentation, let's move on the last part, the main applications of SKAPHIA. Thanks to the WDS technology, SKAPHIA has a very large application range. So as you know, we can probe all the elements of the periodic table, starting from the beryllium. And more particularly with the EPMA, we can probe the fission products like xenon or americium, but we can also easily probe uranium and plutonium. And so the applications are quite large, like nuclear energy power development, nuclear fuel studies, reactor usage optimization, post-irradiation examination, structural materials maintenance, nuclear severe accident simulation and understanding, decommissioning, and finally waste sortage. If you want more information about the applications or the specificities of SKAPHIA, you can download on our website the different brochures, the SKAPHIA brochure and the nuclear materials brochure. And you can also find some application notes and success stories written with our customers. I will end this presentation by thank you for your attention, and do not hesitate to contact me if you want more information or if you have any questions. Thanks a lot and have a good day. Bye-bye.